What's up guys, this is Ren and in this video I am going to discuss another topic. But before that, shout out to my number one supporter, Angel May, and to one of my students, Jebrel, and to my viewers. Thank you very much for your support. Because of you, I have the motivation to continue making videos like this and to spread the fun of learning mathematics. So, in this video, I am going to discuss the probability distribution of a discrete random variable. So remember that a random variable, if you want to learn random variable, you can watch my previous video about random variable and how to find or how to determine the numerical value of our random variable. So before starting this topic, let me recall to you that there are two types of random variable. These are the discrete random variable and continuous random variable. So, a discrete random variable is a random variable with a finite number of possible values or an infinite number of values that can be counted. So, the highlight here is that a discrete random variable, these are the values that can be counted. Example of these are the number of students in the classroom, the number of pages in a book, the number of people in a race. All of these are counting numbers and cannot take a decimal point. On the other hand, continuous random variable. It is a random variable that can be assumed an infinite number of values that can take decimal or fractional values. So the key terms here that a continuous random variable, these are the values or the variable that can take a values that is decimal or fraction. Example of this is the average age of the grade 11 students, the length of a cabinet, and the time taken to finish a race. All of these examples can take fractional values or a decimal value. So, let us discuss what is a probability distribution of a discrete random variable. So, a probability distribution of a discrete random variable is a list, a table, a graph, or a formula of probabilities associated with each of its possible values. So basically, if we take the values of our random variable, we can write or we can create a table for that to determine the probabilities on how many times or what is the probability that the random variable can occur. So these are the steps in making a probability distribution of a discrete random variable. So our focus here is the discrete random variable but not the continuous random variable. So step 1, we are going to determine the possible values of the random variable. Step 2, we are going to construct a frequency distribution table of the random variable. Step 3, we are going to construct a probability distribution table of the random variable. For example, we have this. Consider the random experiment of rolling a tetrahedron dice whose number of dots are 1 to 4 twice. So we construct the probability distribution for the random variable x, which denotes the sum of the numbers. So what we are going to do for this is we are going to construct here the probability distribution for the random variable x, where our random variable x denotes the sum of the two numbers. So the first step we are going to do is to determine the possible values of the random variable. And remember, to determine the possible values of the random variable, we are going to determine the sample space of our random experiment. So for this particular example, our random experiment is rolling, ro rolling a tetrahedron dice twice. So the image of a tetrahedron dice is presented here. So as we have observed, a tetrahedron dice have four faces, and the possible numbers of that are 1, 2, 3, and 4. So to determine the possible values of our random variable, we are going to determine the sample space. So suppose we have a first die, no? The die number 1. If we are going to roll the tetrahedron dice twice, the possible outcomes of that are 1, 2, 3, and 4. So these are the possible outcomes when we roll the tetrahedron dice for the first time. But on the second time, if we roll the die again, we will have, suppose we get 1 on the first outcome, the second outcome are either 1, 2, 3, and 4. Suppose that our first outcome is 2. The second possible outcomes are the same. We have 1, 2, 3, and 4. Suppose that 3 is our number or the outcome for the first rolling of a die. The second outcome is either 1, 2, 3, or 4. Suppose that our first outcome is 4. The second outcomes when we roll a die for the second time is either 1, 2, 3, and 4. So basing on this tree diagram, we are going to have 16 possible outcomes. And we write it here below. So we write here the sample space. So our sample space, these are 1, 2, sorry, 1, 1, 1, 2, 1, 3, 1, 4. We have 2, 1, 2, 2, 2, 3, 2, 4. We have another set. We have 3, 1, 3, 2, 3, 3, 3, 4. Another we have 4, 1, 4, 2, 4, 3, and 4, 4. So these are our sample space. We have 16 outcomes. And then we are going to write our random variable x. So first we make another column. Let me draw a beautiful line here. Okay, that's enough, I guess. So remember that our random variable x, that is denotes the sum of the numbers. So that is our random variable x. Let us look for our example. We have here, oops, sorry. Here we are, the random variable x here denotes the sum of the numbers. So meaning, if we get our sample space or our outcome, we are going to add the two numbers. So 1 plus 1, this one here, 1 plus 1, that is, oops, sorry. 1 plus 1, that is 2. 1 plus 2, that is 3. 1 plus 3, that is 4. 1 plus 4, that is 5. 2 plus 1, that is 3. 2 plus 2, 4. 2 plus 3, 5. 2 plus 4, 6. 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. 3 plus 4, 7. 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, 7. And 4 plus 4, that is 8. So our possible values of x, these are 2, 3, 4, 5, 6, 7, and 8. The possible values of x, the possible values of x are 2, 3, 4, 5, 6, 7, and 8. Oops. So that is the possible values of x. We have a total of 16 outcomes. And we have a total 16 outcomes. A total of 16 outcomes. Alright, so what is our step 2? Our step 2 is we are going to construct a frequency distribution table for our random variable. We are already done with our step 1. We are now going to proceed with the step 2. So how are we going to construct a frequency distribution table? From the word frequency distribution table, meaning we are going to determine what is the frequency or how many times our random variable occur. So here we write another table, or we create another table here. We are going to write x, meaning this is our random variable, and then here we write the frequency. Again, what is our uh, possible values of random variable x? We have 2, 3, 4, 5, 6, 7, and 8. So you write it here below. So the possible values of x, these are 2, 3, 4, 5, 6, 7, and 8. Let us continue this. Alright, so after this, we are going to total the frequency. So how many times does the random variable x equal to 2 occur? So if we count this, we have 1. Here we have 1. Where's the laser here? This one. 1. Alright, so there are only one instance that the random variable x equal to 2 to occur. How about 3? Let's go back to our table. We count this all. We have 1, 2, 2, or 2 times only. So 3, the frequency of getting random variable x equal to 3 to occur, that is just 2. Twice only. How about 4? 4, we have 1, 2, 3, and 3 only. So the frequency is 3. How about 5? 5, 1, 2, 3, 4. 4 times only. How about 6? We have 1, 2, 3, 3 times only. How about 7? 1, 2, twice only. How about 8? 1, once only. Okay. So if we add this all, we have 1 plus 2, 3, plus 3, 6, plus 4, 10, plus 3, 13, plus 2, 15, plus 1, 16. We have a total of 16. And remember, what is 16? That is the total outcomes of our sample space. And then the last step that we are going to create is we are now going to construct a probability distribution of the random variable, which is the discrete random variable. So this is now our last step. All right. Let me expand this one. Okay. Expand. Okay. So to create a probability distribution table, we write here our random variable x. And then we write another uh, line here like that. And then probability of x. Remember, p of x, this is read as the probability of random variable x, or the probability of x. So remember that our random variable x have the value 2, 3, 4, 5, 6, 7, and 8. And we spread this line here. Now, what is the probability of getting 2? If we look here to our frequency distribution table, the frequency of getting 2 is once only. Once only from the 16 outcomes. So we write here 1 over 16. Now, what is the probability of getting the sum of 3? If we look over here to our random variable x equal to 3, we have a frequency of 2. out of 16. So meaning the probability of getting a sum of 3 that is 2 over 16 or 1/8. How about 4? Getting the sum of 4. The frequency of that is 3. So we write here 3 over 16. How about getting the sum of 5? If we look here, the frequency of getting the sum of 5 that is 4 out of 16 outcomes. So the probability of getting the sum of 5 is 4 over 16 or 1/4. How about getting a sum of 6? If we the frequency of getting a sum of 6 that is 3. So we write here 3 out of 16 outcomes. How about getting a sum of 7? We have 2 here over 16. How about getting a sum of 8? Right, we can still reduce this one into lowest term. So 2 over 16 or 1/8. Oops, sorry. How about getting a sum of 8? We have only 1, right? Because the frequency is 1. So 1 over 16. This is what a probability distribution table looks like when we perform a random experiment rolling a tetrahedron dice twice. So basically, we are just assigning a probability to our random variable x. So the probability of getting a sum of 2, that is 1 over 16. The probability of getting a sum of 3, that is 1 over 8. The probability of getting a sum of 4, that is 3 over 16. And the probability of getting the sum of 5, that is 1/4. The probability of getting sum of 6, that is 3 over 16. And the probability of getting a sum of 7, that is 1/8. And the probability of getting a sum of 8, that is 1 over 16. Now, let me ask you a question. Suppose that you are gambling with your friends and you are betting enrolling a tetrahedron dice twice where you are going to determine the sum of two numbers. Where are you going to bet? The sum of getting 2, the sum of getting 3, the sum of getting 4, the sum of getting 5, the sum of getting 6, the sum of getting 7, or the sum of getting 8? Most probably, if you know how to write or to create a probability distribution table, you are going to bet on the sum of getting 5. Why? Because the probability of getting a sum of 5 is 1/4. 1/4 is the highest value among the rest. So meaning getting a sum of 5 have the highest chances of getting have the highest chances than getting a sum of 6, 7, 8, 4, 3, and 2. So that's it for this video and see you to my next video. Goodbye.